A group of students design and carry out experiments to deduce the formula of two salts, X and Y. X contains one cation and one anion, so that's one positive ion and one negative ion. Y contains water of crystallization, that means it has some dot XH2Os at the end. A sample of X is warmed with sodium hydroxide and the gas turns damp red litmus paper blue. That is the test, and we just have to learn that for an ammonium ion. Just say give the formula, so we can't write the word ammonium, we must give the formula. A sample of X is placed in a test tube and dissolved in deionized water. It's acidified with acid and then barium chloride solution is added. Now this is the test for sulfate ions. So our negative ion is the sulfate ion. Deduce the formula of X using your answers to A and B. So I have to put those together, but the positive ion is only 1 plus, so we'll need 2 to balance the 2 minus of the negative ion. Y is identified as hydrated potassium carbonate. Two students were asked to determine the number of moles of water of crystallization, this value of N, using the procedure. Weigh a sample of Y into a pre-weighed crucible, place a loose lid on the crucible and heat for 5 minutes to remove the water of crystallization. So my K2CO3.NH2O is being heated to remove the water of crystallization. We're allowing it to cool, reweighing the crucible and its contents. The first student carried out the mistake but forgot to use the lid. Explain how this would affect the value of N. So if you don't have the lid, some of the salt would be lost during heating. What could happen is it could start to spit because of the heat, the hot Bunsen underneath the crucible. So some of the salt could be lost. Now, if you lose the salt, you assume that you've lost water because everything you do in your calculation is you get a mass, let's make up a number, say you had 100 grams of this. After heating, and you weigh it again, it now weighs 80 grams, you assume that everything you lost here is the water. Now, if you lost some of the salt, then this number should be 80 grams, but you're going to assume that you lost, it's weighing 75. You're going to assume that extra 5 was water. So what that means is the water ends up being bigger than it should be. So N is greater. The second student carried out the experiment but heated it for only 1 minute. So if you heat it for only 1 minute, you don't heat it long enough. Maybe only 5 grams of the water is evaporated and the rest of it is left as salt. So you assume that you've heated it long enough, but you haven't. And so the amount of water you remove is too small, your N is less. We always heat these until constant mass to prove that all the water is removed. In an accurate experiment, it was found to consist of 71.9% by mass potassium carbonate. So that means that the rest of the mass must belong to the water. So we're going to do 100 minus 71.9 on our calculator and get 28.1. Like everything in chemistry, we're going to convert to moles by dividing by the MR. So we know that water is 18. So if we do that one first, we get 1.561 as our moles of water. We need to add up potassium carbonate. So using the periodic table, you can get the MR, 138.2, and we can divide 71.9 by 138.2 to get 0.520. So for every one of these, there are 3 waters, so that makes N3.